Okay, so today we are going to be covering 6.5, which is graphing inequalities. It is very similar to graphing equations. We just have some slight differences. So let's talk about what a linear inequality is. So a linear inequality will replace an equal sign in a linear equation with an inequality sign. Okay, so the only difference between a linear equation and a linear inequality is that it replaces that equal sign and gives it an inequality sign. So for example, if I had the equation y equals x minus 3, if I wanted to change this simply straight into an inequality, bless you, I would change this equal sign to one of any of the inequality signs. How many inequality signs do we have? Let's name them off. So what do we have? What?
Greater than.
Greater than. Less than. Greater than or equal to. Less than or equal to. Okay, so you got your four main ones. Okay, so I'm just going to pick a random one. So let's say y is greater than x minus 3. Okay, this now is in a inequality. Okay, just by replacing the equal sign to any of the four inequality signs, it can become a linear inequality, but the slope still stays the same. The y-intercept can still stay the same. Everything else about it can stay the same. Okay, so that is one of the differences. So again, we have greater than, less than, greater than or equal, or less than or equal. Okay, these are different inequality symbols. Greater than, less than, greater than or equal, or less than or equal. So any of those four symbols you'll be seeing today as we work. Now, when we are graphing, because it's an inequality, we will end up doing two different things. So we're going to write out some steps just to clarify those two different things that we will have to do because it's now an inequality versus an equation. Okay. Okay. Step one, I've had someone ask me the other day, like, why do you put S1? It's for step one. So you know it's not a problem. It's a step one, S1. Okay, so step one in graphing inequalities is to graph the inequality. If I can spell it correctly, hold on. Like it was an equation. So the first step is just to graph it like it was an equation, meaning you're going to start with the, what do we start with when we graph? What do we start with plotting first? We start with the y-intercept. And use the slope to find more points. Okay, so those two things are the exact same thing. We start with the y-intercept and we use our slope to find more points. So that first step is the exact same from when you did it with an equation. Step 2 and step 3 is where it differs just slightly. In step 2, however, normally once we have all those points, what do we normally do in an equation? Draw a line. However, because it's an inequality, we have 2 different types of lines that can be drawn. So you have to determine the type of line to draw. You have to determine the type of line to draw. Now, let's remember back when we did normal number lines and we did inequalities. What was the difference when we drew a number line? What was the difference between those signs when we did it on like just a basic number line? How did we indicate the difference between these types of symbols? The circle, good. And what was different about the circle? It was shaded in or shaded or without shading, right? It was open or closed circle, right? So similar, yeah, shaded in or shaded not. So a similar concept, we are going to have either a solid line or a dashed line to indicate the differences. So when we have greater than or less than, rather than having an open point, we have an open line. So it's a dashed line. Okay. Okay, you might hear the phrase dashed or dotted. I always say dashed because you're more likely to actually make dashes versus a dotted line. Now, when it's printed, normally the computer automatically makes dots versus dashes. So again, dashed or dotted, doesn't matter. And then if you were doing a greater than or equal or less than or equal, similar concept when we did number lines, we had a solid circle, so we have a solid line. So just a normal line. So again, that draws from when we did number line, where you had an open or closed circle. So now you have an open or closed line. Okay, and that stems from those inequality signs, right? Because if it's or equals, everything works. But if it's just less than or greater than, it works, but it doesn't actually hit that number exactly. So that's why it's an open line. Okay, so that's step 2. Pretty easy difference. Okay. Step 3. Now, because it's an inequality and it's not just a equals, what did we do else? What else did we do when we had a number line? We did open or close line, but then what else did we do?
You would shade the direction where the number would be.
So we are also going to have to shade on the graph. I know. So how are we going to do that? You're going to use a test point to determine which part of the graph should be shaded. You're going to use a test point to determine which part of the graph should be shaded, because on a number line, our choices were left or right. But when we have our lines, it might be up left, bottom right, it could be top, bottom. It just really depends on how that line looks. So I can't just simply say one direction or the other. It's going to look a little different. Okay, same concept, similar concept, but it'll look a little different. Now, when we're picking a test point, I want to pick a point that essentially I'm going to use to substitute in to see if something is true or false. Now, you could technically pick any point you wanted to pick. You could pick 100, 100, you could pick negative 10,000, 2 billion. It doesn't matter. You can pick whatever you wanted, but the point cannot be on the line. Meaning if I picked a point, I couldn't pick like the y-intercept because that point is on the line. Okay. Now, the most common test point is going to be the easiest numbers you could use for substitution. What are the easiest numbers you could use for substitution? 1, 1, is a pretty easy one. What would be something even easier than 1, 1?
0.
0, yeah. The easiest test point is 0, 0. Because multiplying by 0 and adding 0 is really easy. Now you could pick 5, 5, you could pick -10, 20, you can pick whatever you want. But 0, 0 is going to be your easiest test point just because of the multiplication and adding of 0 is easy. Okay.
Dividing by 0 is where a computer gets drunk.
Well, you don't need to divide by 0. All right, so let's talk about what happens when we test that test point. Okay, so if the test point is true, now again, I'll explain this a little bit more when we actually use a test point, but we're going to write it down here first. If the test point ends up being true, once we submit, and I'll show you how we're going to do that in a sec, then you will shade on the side of the line where the test point is. If the test point is true, whatever test point you pick, then you're going to shade on that side of the line where the test point is. Now, if the test point is false, then you will shade on the opposite side of the line where the test point is.
Finally, getting the wrong answer gives you the right answer.
Yeah. And again, we'll explain this here in a second when we're actually looking at the problems, but I wanted to write this all down and then we'll switch over to the graph paper and we'll just follow back and forth. Okay. Now, this part is a little confusing. Obviously, we'll get to it when we're doing the examples, but I can't simply just say shade left, shade right. Okay, because again, our lines could be horizontal, they could be vertical, they could be diagonal, diagonal to the left, diagonal to the right. So I can't simply just say shade left, shade right. Okay. So make sure you have this written down, and then we're going to go to our graph paper and practice this concept. Okay. Anyone need more time with writing? I see a couple people, that's okay. Bless you. Does anyone need more time? Okay, we will be doing 6 graphs today, just a heads up. So wherever you're starting on your page, we're going to be doing 6. I have a pile of these printed out. They're just sitting on top of the homework box. So if you need them, please grab them. But again, we are running out of ink in the school. So please, 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 please keep your papers safe so that we don't have to get a new one every single time, because they are double-sided, so you can use them for a long time. All right, so number 1, and again, remember, if you have all the multiple graphs, make sure you label, like this is starting 6, 5, so you know where you're looking at. All right, number 1, we are going to graph y is greater than x minus 2. I'm going to zoom in Make it a little easier for us.
Didn't we just do this, but it was -3?
Yep. Okay. So what do we start with? We start with our y-intercept. Now, please, I know it's been a week, but let's remember, how do we say a y-intercept? What should the coordinate point be of the y-intercept?
0 y-intercept, which in this case is -2.
Good. So we're going to start at the y-intercept of 0, -2. Again, I'm going to make obnoxious points. You do not need to make them as big on your piece of paper. Okay. The whole point of that was saying that don't just say -2 is the y-intercept. Remember, y-intercept has to be a coordinate point, 0 and then a number. In this case, 0, -2. Okay. What is my slope in this situation? My slope is not x. That's a common answer. Yep.
1.
All right. Slope is 1. Remember, there's an imaginary 1 in front of the x, which is what represents the slope. Now, how do I actually find a slope when it's 1? What am I doing? Up, down, left, and right? What number is technically 1 divided by 1? So I'd be going good, up 1 to the right 1. Over and over and over and over again. Right. Again, when we have a slope of 1, technically that's 1 over 1. They're both positive, so you're going up 1 to the right 1. Now I've gone as far as I can going up, so I got to go backwards, which would be meaning going down 1 to the left 1, over and over and over again until I've hit my end. Now, once you get to that point, don't draw a line yet, because we have to look at step 2 and indicate if we have an open or closed line. Okay, so looking at my inequality sign, I want to determine what type of line am I drawing. So because I have a greater than, is this going to be an open or closed line? Open. Okay. Now, the easiest way to go about that is just drawing dashes every few points. So I draw a dash, skip a couple, draw a line, skip a couple, and just kind of do, okay. And you have an open dash line. Okay, you have all those points. The biggest thing is it has to look open. So you need to skip a couple every so often so it doesn't look like it's actually connected the whole way through. Okay, so that's step 2. Step 3 is the part where you got to think a little bit more. We got to do that test point. Okay, so we want to determine, are we going to shade on the top left portion of this or the bottom right portion of this? Now, can I use the test point 0, 0 in this situation? Is 0, 0 on the line? No, so therefore I can test it. Okay, so let's clarify. My test point, which you can shorthand as TP. My test point is 0, 0, so you need to indicate what point you're using. And you are simply going to substitute 0 for X and 0 for Y. So Y would be 0, which is greater than X, which is 0, minus 2. So I'm substituting in the zeros. We all see where we're substituting those in from. Ah. All right, do we all see where the 0, 0 is coming from, substituting in? Okay, then we just simplify, okay? What's 0 minus 2? -2. So what your goal is to get down to a statement of a number greater than, less than, greater than or equal, less than or equal a number. And then we determine, is that a true statement or a false statement? So is 0 greater than -2? True. This is a true statement. Now, what side was 0, 0 located on my graph? If I plotted 0, 0, is it on the left side or the right side? Left side. So therefore, because it's true, I should shade on the left side. Okay. Simple shading will do like this. Okay. And we are done with that problem. Thank you. Okay, now when you go for shading, this is enough shading. You don't need to fill it in completely. Don't waste your lead. Okay. Also, you want to double check sometimes. Now, obviously, we're doing these together, but before you shade on your homework, just do a double check in your head. Okay, I tested this point. Yes, this is true. I'm shading on the side, because once you shade, it's a lot harder to erase that all and then try and shade the other side. Okay. So, but that's the end of that problem. So do you see the differences between equations to inequalities? Yes, no, maybe so. All right, let's try number 2. Number 2, y is less than or equal to negative 2/3 x minus 1. Y is less than or equal to negative 2/3 x minus 1. Okay, so where's my y-intercept? Where are we starting at? 0, negative 1, good. And then we have a slope of negative 2/3. What does negative 2/3 mean for how I'm moving up and about on the graph? So I could go down 2, yeah. Yep. So I could have gone down 2 to the right 3. I also could have done the opposite direction, would have been up 2 to the left 3. Remember, if you have negative slope, only one of the numbers is considered negative. Okay. Right, now continue that pattern, down 2 to the right 3, or up 2 to the left 3. Should this be a solid or dashed line? This should be a solid line. Good. Oh, I should pass out the ruler, sorry. Remember, there needs to be arrows on the end. I'll pass out the ruler here on the next problem. Okay, go ahead and test your test point. Can we test 0, 0 on this one? Yep. So don't shade, just test it. See what you get. A true or false statement. See what you get. Okay, let's see what we should have gotten if we test 0, 0. So it would be 0 is less than or equal to negative 2/3 times 0 minus 1. Again, wherever x and y is, we substitute 0. Okay, now what you want to be careful about is that you actually keep the slope written in there. Okay, on this one, the slope was 1, so it didn't affect us. But you need to keep the negative 2/3 written there. Okay, now what happens when you multiply negative 2/3 times 0? what do you get? 0, okay? So you get 0 is less than or equal to 0 minus 1. What's 0 minus 1? -1. Okay. Is 0 less than or equal to -1? 0 less than a negative number?
Oh, wait.
No, so this is false. Okay, now where is 0, 0 on my graph? Is it on top or bottom? It's on top, so therefore, because it's false, I should shade on the bottom. Okay, and just to clarify what we did there, okay? Again, on step 3, which is very zoomed in, so it's hard to see right now, but remember, if it's false, you shade on the opposite side of the test point. Now, for some people that confuses them, the opposite side. So some people will just pick a different point to make sure it is true on the other side, and that's fine, but you don't have to do that. Okay, just know that if you have a true statement, you shade where that point is. If it's false, you shade on the opposite side. Okay, does that make sense? All right, let's see about number 3. Y is less than or equal to 1/2 x. Y is less than or equal to 1/2 x. Okay, I want you to start off by just plotting the points, and then we'll check back in together. Start by plotting the points, and we'll check back in together. All right, check with someone near you if your points line up. Check with someone near you, see if your points match up. Okay, it looks like most people are getting some matching graphs based on just the communication I see. So where should we be starting on this graph for our y-intercept? 0, 0. Remember, if there's not anything plus or minus added to this, that means you are starting at 0, 0. So my slope is up 1 to the right 2, or down 1 to the left 2. And I'll do that real quick. While I do that, should this be an open or a closed line? It should be closed, good. Remember, arrows on the end once you connect them. Okay, now what is the issue going to run into here when we go to do our test point? Can I do the test point that we've been loving so far? No, we can't do 0, 0. Why? Because it's on the line, okay? I can pick any other point I want though. Now, the most common backup test point is 1, 1, which works here. It's just barely above the line, which is fine. But you could go crazy. You could pick 5, -3. You could pick 4, 5. You could pick whatever you want, whatever your heart desires, as long as it is not on the line. Okay, so go ahead and pick a test point. I want you to pick whatever test point you want to pick and test it out. It cannot be on the line, however. You can pick any point except for the points you just plotted. Pick whatever test point you want to pick, as long as it's not on the line. All right, show your neighbor what test point you picked and what way you think it should be shaded. Now remember, your test points could be different, so you could be having different true or false statements, but you could still be shading the correct way. All right, bring it back to me. All right, someone tell me what test point they picked.
-1, -1.
Sure. Okay, now this is just one example of a test point you could have picked. You could have picked any test point other than on the line.
500, 300.
Okay, so test point -1, -1 is fine. So -1 is less than or equal to 1/2 times -1. What is half of -1?
-1/2.
-1/2. Okay, is -1 less than or equal to -1/2? Yes.
Hard to think about because
Hard to
-2
think about because of the
is-
negatives, right?
yes.
So, like I said, you can pick whatever you want. Obviously, negatives sometimes can make your life a little bit trickier in your brain.
I like
That's
it. It's
okay.
actually fun.
So if we picked -1, that is a very close point to pick, but it is okay because it is true. And you should be shading down. Now, again, you could have picked any test point. So this is just one example of a test point you could have picked. But raise your hand if you did believe it should have been shaded down. Okay, good.
After all, I'm the one that picked the point.
Okay, questions or concerns that came up while we were looking at number 3? Any? Okay, I'm gonna give you number 4 then. X is less than -3.
What?
X is less than -3. Okay, go ahead and try that and we'll come back together here shortly. All right, go ahead and check or work with someone near you to look at number 4. Okay, so what type of special case scenario is this? What's this line gonna look like? It has 0 slope, which means it looks like what? So, and that line would be oriented what way? Vertical. Okay, so let's remember our special case scenarios. They're the exact same special case scenarios we've been working with for the last month. Okay, we have multiple lessons over these special case scenarios. Okay, remember I taught you the acronym POIVUX to remember horizontals, all those different things. So it's not 0 slope, it's undefined slope. Okay, because it is a vertical line at -3. Remember, if X equals -3, then it would be -3, 3, -3, 8, -3, -7, -3. All your lines, all your points would end up being vertical. Now, should this be a dashed or solid line? Nope, should be dashed.
They should.
Now, it's very hard to show a dashed line on a line that's already there. You kind of just have to make it, yeah.
I mean, really long, thick dashes, but it's obvious that they're not
Yeah.
connected. So it's just literally just like 3 lines.
Yeah. Okay, now, could I do the test point 0, 0 in this scenario?
Yeah.
Yes. Now, when I go to test point, is there a place for me to actually substitute the 0 for Y? No, but I could still substitute 0 for X, right? So it'd be 0 less than -3, right? There's nowhere to put I'm not gonna put X there. Let me try that again. There's nowhere to put that, right? I don't need to put anything for Y because there is no Y. Is 0 less than -3?
Yeah.
Is 0 less than -3?
Totally.
No, that is not true. 0 is not less than negative numbers. And where is 0, 0 on my graph? On the left side or the right side?
To the right.
To the right. So therefore I should be shading to the left.
That's all you see when you look at that because you're going so fast and the frames are so slow that you see.
Oh, you can see it jump. Yeah. All right, questions or concerns that came up on number 4? Okay, focus. Questions or concerns that came up on number 4? A couple things. And notice we completely forgot our special case scenarios of vertical and horizontal lines. That's one issue that we need to remember. Okay, they're always the same. X by itself is always vertical. Y by itself with no X is always horizontal. Okay, 0 is never bigger than a negative number. That was another concern I had while we were going over that. Okay, so remember that. Okay, don't shade wrong because you forgot what numbers are smaller or bigger than the other. Okay. All right, on 5 and 6, they're going to be a little bit different and they're going to be a little bit difficult for notes just because it's a little harder to see. But for 5 and 6, I am going to present you a graph and you're going to tell me what inequality is graphed, essentially going backwards. Okay, so I'm going to present you in a graph. You're going to tell me what the inequality was. I'm going to zoom in as much as humanly possible. And to make it easier, I'm going to tell you 2 points and then you can figure out the rest from there. Okay, so one of the points is 2, 1. So plot that point. One of the points is 2, 1. And another point is 4, 4. One of the points is 2, 1. And another point is 4, 4. Following that pattern, keep putting in more dots and represent this graph, and then figure out what inequality represents that information. Just a little critical thinking, working backwards. Try this out. Okay, remember you're looking for where does it start at the y-intercept and what is the slope between the 2 points. Okay, start with that. And then you got to figure out which way is it shaded and what type of line is it based on what inequality sign should be. Okay, go ahead and work with someone near you on this first one. Let's see if you can brainstorm together. All right, let's talk this one through. So let's go even further back. Is this going to be a special case scenario where y or x is by itself? No. So we already know there's going to be a y, and we know there's going to be some kind of symbol, some kind of slope, x, plus or minus something, right? Okay, let's figure out the plus or minus something because that's where our y-intercept is. What should I be adding or subtracting to the end of my equation based on my y-intercept? -2, good. Okay, because I'm starting at 0, -2, I'm going to be minusing 2. Okay, next I want to figure out what is my slope that goes in front of x. So how am I going to get from one point to the next? What should my slope be? 3/2, good. My slope is 3/2, good. Now I got to figure out my inequality sign, okay? Now, based on my inequality signs, I know it could either be greater than, less than, greater than or equal, or less than or equal. Which ones can I eliminate off the bat? Good, I can eliminate these off the bat because I know it's a dashed line. Okay. What do you think we should do to consider which one it is greater or less than? What are your thought process? Should it be greater than or less than? How could we consider that? How could we figure that out? Get a test point? Good. So if I did a test point, could I pick test point 0, 0? Yeah. Now it'll look a little weird because there's no inequality sign, but 0 something, 3/2 times 0 minus 2. What's 3/2 times 0? 0. Question mark, question mark. What's 0 minus 2? Right. The question is, what should go here? And do we need it to be a true or false statement? So 0, 0 is in the shaded part. So we need this to be a true statement. So is 0 greater than -2 or 0 less than -2? Greater. So therefore, my inequality should be greater. Question concerns. How do we do on that one? It's definitely a critical thinking type question. Okay, but it'll get easier. Any questions or concerns before I let you try number 6? All right. So do you have any questions before I move to number 6 for you to try? Oh, gotcha. I thought you said, can I slow down? I was like, okay, hold on. What do you need? So no, I get that. Thank you. All right. Now try number 6. This is your last one for today. Try it number 6, same concept. Where's the y-intercept? What's the slope? Indicate what type of line so you know what type of symbol. All right. I'm going to give you 2 points to get started just to help you out visually. All right. One of the points is -10, 7. And another point is -5, 5. -10, 7 and -5, 5. Get you started. Try it out. Check or work with someone near you to see what you think it should be. Okay, would anyone like to offer up what they believe the inequality should be? Christian?
Y is less than -2/5
Correct. Y is less than or equal to -2/5 x plus 3. Yes.
Actually, if I'm allowed to correct, it is less than or equal to, because it is a straight filled line.
Less than.
He said
Oh,
it's less
he,
than.
okay, sorry, less than or equal to, correct, sorry. I wrote the right one. But yes,
Okay.
sorry, let me zoom out here a second. Let's talk about how we got there. Raise your hand if you got that. Okay, so first we start off with our y-intercept, which is 0, 3, so that's where we get the plus 3. Then we count our slope, which was up 2 to the left 5, which is a -2/5. From here, we got to pick our test point and indicate what sign. So we knew that it wasn't going to be the regular ones. And then figuring out a test point. Now you could have picked any test point. If you picked 0, 0, then that would have been a good one to work with, but you could have picked any test point to prove that. Any questions or concerns regarding that one? Okay, that is the end of the notes. So let's pass out homework.